Okay, 6.1 is ratios, rates, and we're actually going to do something called dimensional analysis. So it's going to be on a separate sheet of notes. So we're going to start with ratios, rates, and unit rates, which should be fairly familiar. A little bit of review. We'll add some new things onto it, of course. So what is a ratio? A ratio is a comparison of two numbers by division. There are three ways to write it, a ratio. So let's say that I had 4 girls and 3 boys, and I wanted to compare the number of girls to boys. So one way to do that is to write 4 to 3. Notice you don't label them, you don't put girls and you don't put boys, you just say 4 to 3. Because the sentence would say, what is the ratio of girls to boys? And you would write it in that order, 4 to 3. The other way you could write it is with a colon in between, and you've probably seen that more, but when you say it, you still say 4 to 3, like this. The last way to write it is in fraction form. It is not a fraction, it is a ratio in fraction form. So you don't say 4/3, you still say 4 to 3, okay? The next one is a rate. A rate is a special ratio. It's a ratio of two different kinds of measures. So 65 miles in 3 hours. I drove 65 miles in 3 hours. Those are two different types of measures. One is distance, one is time. That is a rate. I paid $16 for 2 pounds. Money and weight, two different kinds of measure. Those are rates. Now, grocery shopping, or even like if you're looking at cars, there's times that you want to know a unit rate. So sometimes when I go to the grocery store, I like to know which one is cheaper. Should I get the 12-pack? Should I get the 24-pack? Should I get a 48-pack of whatever it is I'm buying? And because sometimes it's cheaper for the one where you have more, and sometimes it's not, depending on the sale. So what I do is I like to find the unit rate. I want to know the cost for one of that item. It might be in a box of 48, but what would it cost for just one? Because maybe it's cheaper for me to buy a bunch of 12s instead of one 48. So a unit rate is a rate with a denominator of 1. So if I take that $16 for 2 pounds and I turn it into fraction form, what I'm doing is I'm turning the denominator into 1, so that means you have to divide by 2. So essentially you're just taking the top number and dividing it by the bottom number. That's the quick way to do that. So what you would get is $8 on top for 1 pound, and usually when you write rates, you write the per as a slash, so $8 per pound. You don't put the 1 pound, you just put pound. Okay, like so here I would put 1 pound, but here I do not. So the faster way to do this is to do top divided by bottom to get a unit rate. What is the difference between a ratio that compares measurements and a rate? I'm going to put a thing here. Ratios have to have same units. And we'll get to one of those in examples. When you write a ratio has no labels. Therefore, any of the units that are measurements, they have to all be in the same measurement. However it's written, whatever's written first should be on the top, whatever's written second should be on the bottom. It says that they want us to write it in fraction form and to make sure it's in simplest form. So if I'm comparing 8 pencils out of 12 pens, the ratio of pencils to pens is 8 to 12. I can divide both of those by 4 and I'll get 2 to 3. 42 textbooks to 28 students. The first one is 42 textbooks to 28 students. I'm going to divide them both by 7, let's say, and get 6 over 4. Oh, let's divide it now by 2, and I'll get 3 over 2. So 3 to 2 is my ratio of textbooks to students. I have 3 textbooks for every 2 students. All right, these 2 are special ones. So I'm going to put stars next to them because I put a star up here. Ratios have to have the same units. So because these are units of measure, they must be in the same. You can't compare gallons to quarts. You compare quarts to quarts and gallons to gallons, and that's about the only way you can do that. So here's how I do it, because sometimes it's confusing to try and figure out, should I divide, should I multiply? So this is what I do to help me figure out the conversion to make them the same. So I will put my 3 gallons on the top and my 15 quarts on the bottom. And so what I do is I'm trying to cancel out the units. I want the gallons and quarts to cancel out because remember we have no label, so I'm going to cancel them out. To do that, I'm going to cross cancel them. So I'm going to change the units. I'm going to flip them around on the other side so that when we're done, we'll be able to just cancel all the units and I'll just have numbers to multiply, fractions to multiply. Now in the front of your packet, you will have one of these charts. So there has to be numbers here. There's no numbers right now. I have a 3 to 15 here, but I need to know the ratio of quarts to gallons. So on your sheet, you'll see quarts to gallons. It looks like right here I have 1 gallon to 4 quarts. So I would come over here and say 1 gallon, 4 quarts. Make sure they're by the right numbers. Now when I go ahead and go multiply across, I'll have 12 on top, 15 on the bottom, reduces to 4 to 5. I've got 30 feet to 11 yards. So I got 30 feet, 11 yards. They have to cancel out those units. I can't have different units. So I'm going to put the yards up here and the feet down here. And this will help us with our dimensional analysis in a bit too, with crossing out units. The units will all cancel out. But I do need to know my yard to foot ratio. You should know this one in your head, but if you don't, it's 3 feet to 1 yard. It's on your sheet. All the units are on your sheet. So it's 3 feet to 1 yard. Make sure you put them in the right spot. You can cross cancel or just multiply across the top and multiply across the bottom. Oops, that should be a 33. Let me fix it. 33. Divide both of those by 3 and you get 10 to 11. You could cross cancel here like you can in multiplication. So make sure anytime you have units of measure that you get rid of the units. We're going to make a unit rate. So when we make a unit rate, we have our $9 over our 6 cans. You don't have to label yet. You'll label at the end. So let's put a label here. I said that you could do top divided by bottom. And you have your calculators. Any calculator will do. So I'm just going to do 9 divided by 6. And because this is money, it needs to have 2 places. And here you see that there's only 1. So after the 5, I would need to add a 0. So it's $1.50 slashes the per. And then what were these? They were cans. So $1.50 per can. I have $39 for 75 bananas, and I want to find out how much per banana. So I'm going to do 39 divided by 75, and it looks like 52 cents. So $, 0.52 per banana. Okay, let's do one more. 108 miles in 6 days. So I go 108 divided by 6. Looks like I can go 18 miles per day. Okay? Next section is ratios with fractions. So your ratio with a fraction is 1/2 to 1/6. Now that looks pretty ugly because it's a fraction and a fraction. But what does a fraction bar mean? It means divide. So this is really the same as 1/2 divided by 1/6. And this is going to help us to reduce it a lot easier than trying to find common denominators or multiples. So this really means divide, so I can do 1/2 divided by 1/6. I'm going to keep, change, and flip. And now I'm just going to cross cancel. 3, 1. Now, because it's a ratio, we leave it like this. So even if I get impropers, remember this is not a fraction. This is a ratio comparing two things. So I still need to have two numbers in my final answer. Okay, so 3 times 1, 1 times 1. This one would be 2 to 3 this way, right? So it's 2/3 over 3/4. So that's like 2/3 divided by 3/4, which means I will keep, change, and flip. Multiply across the top, you get 8, bottom, you get 9. Okay. Next, I want you to flip to the page that looks like this. We will use this conversion chart a lot when we're doing this. It's called dimensional analysis. You'll do it a lot in chemistry with really big, long T-charts, but it's a way of converting when you have one unit or more units. So what we're going to do are some two-step conversions, and I call these T-charts because it looks like each section is a T. So we're going to use T-charts to help us make our equivalent ratios because it's a lot easier to keep it straight. So what happens here, in a T-chart, you can cross-cancel, I'm going to put the units, just like I did on those ratio ones. You can cross-cancel the units in a T-chart to complete the conversion. So do you see this thing here? That's your bar, okay? That's your bar here. Where this first number would go on the top and this unit will go on the bottom, okay? And then here's your bar again. In the last section, this will go on the top, and this will go on the bottom when you're changing them, okay? So this entire part is your left ratio. And let me show what I mean. So I'm going to make a double T-chart because I've got 2 units converting to 2 other units. So I'm making a double T-chart. This whole thing is the left side. So I've got 45, I said that 45 miles would go on the top and the hours would go on the bottom, but that's just 1 hour because it says per hour. Each section I have to change 1 unit. So let's say that I want to change the top unit first. I'm going to ignore the bottom one. We need, just like on the ratios, to be able to cross-cancel these units out. And what am I changing it to? It's going from miles to feet. So miles goes on the bottom because I want that to cross out because I want a new unit of feet. The feet won't cross out. I need them to stay. So I just fixed this one. Next, I'm focusing on the hours. Hours needs to be cross-canceled because it's going to be changed to, you look over here, seconds, and seconds has to go on the bottom because it's listed second. All right, the hours and the miles will cross out. I use this for my conversions. I need a feet to mile conversion. How many feet? 5,280 to 1 mile. So 5,280, 1 mile. Hours and seconds. So here's my hours and seconds. Some of them aren't listed and I added them. 1 hour is 3,600 seconds. So 1 hour, 3,600 seconds. So I take my calculator, trusty calculator here, and I have 45 times 5280. Nope. Okay, 5280. I get 237,600. On the bottom, 1 times 1 times 3,600 is just 3,600. You will divide and you'll get a decimal answer or a whole number. So this one happens to be 66. Okay, let's do another one. This whole thing's going to be first. So I have 26 centimeters on top, 1 second on the bottom. I need to change the first top to, to meters, centimeters to meters. So meters has to be on the top. Diagonally across is the centimeters because that's going to get crossed out. So my centimeter to meter conversion is on here. Centimeters 100, meters 1. Centimeters 100, meters 1. Then my seconds are going to be on the bottom, or are on the bottom, and need to change to minutes on the bottom. That means diagonally across needs to be seconds to cancel out, because I want meters and minutes left. Okay? So seconds, there's 60 seconds in a minute. That one I knew. I'm going to do 26 times 60. That gives me 1560. And on the bottom it looks like I have 100. So when I divide by 100, I get 15.6. Okay? First one goes on the top, or on the left. 2.5 quarts on the top, 1 minute on the bottom. Okay? Gallons has to go on top. Over here, hours has to go on the bottom, if that's helpful. Diagonally across, so I have gallons on the top. Diagonally across, the quarts have to cancel out. Over here, diagonally across, because you ignore this, the minutes have to cancel out. So gallons and quarts. We said 1 gallon, 4 quarts. 1 hour is 60 minutes. So then I take my calculator, 2.5 times 60. I get 150 on the top. 1 times 1 times 4 is 4. When I divide that, I get 37.5. Okay, one more. 4 cups, 1 minute, because this whole thing is the left ratio. I'm changing cups on top to quarts, so underneath the cups have to be able to cancel out. I'm changing minutes on bottom to hours, and diagonally across, minutes has to go here to be able to cancel out. That's my conversion. So cups and quarts. 1 quart equals 4 cups, and 1 hour equals 60 minutes. So I will get 4 times 60 is 240. The bottom I get 4, and when I divide those, I get 60.